So, hello, in this video, I'm going to go through 5.12. So we're going to go through area and volume. And as you can see, there are 10 sections in here in Cognity. You can use Cognity as a resource, but I'm not going to require you to read through all these sections. But by all means, if you want to do the checkpoint questions, you can do that. So I'm going to go through this is the packet that I gave you before the lockdown. And I'm going to go through some of these problems. And the ones I don't do, you can try on your own. So I'll go through this first section. These are properties of integrals. So you can't really use your calculator here because you don't know the functions. And so they're just giving you things about two different functions, f of x and g of x. They're saying like the area under the curve of f of x from 1 to 6 equals negative 2. So you have to imagine, some curve from 1 to 6, and they're saying the area under this curve is equal to negative 2, which would actually mean that it can't look like this. The area would have to be going underneath the x-axis from 1 to 6. So technically you could have an area that's negative if it's below the x-axis. If it's above, then it's positive. Okay? And then you've got other pieces from 1 to 10 equals 5. And then this is for a different function, g of x. So based on this given information, we have to figure out what these values are. So 2 times f of x, if we know from 1 to 6 is negative 2, then this is just doing 2 times negative 2, because we know from 1 to 6 the area under the curve of f of x is negative 2. So we just do 2 times that. And then plus the area under the curve of g of x from 1 to 6 is equal to 4. So we're just doing 1/2 times 4, and we just calculate this. Negative 4 plus 2 is negative 2. So then the area under the curve from 10 to 6 of g of x. So if we know from 6 to 10 is equal to 10, then if you reverse the order of, notice this goes from 6 to 10, but this goes from 10 to 6. If you reverse the order, you just reverse the sign. Okay, and you could test that out with any function. If you just plug in a function g of x and reverse the order, the sign is going to change. So then let's do another one. From 1 to 10, 3 times g of x. So we're given from 1 to 6 and from 6 to 10. So really we could deduce that from 1 to 10, g of x must be equal to the sum of these two. Because this goes from 1 to 6, and this just picks up right where it left off. So the sum of those would be 14. So from 1 to 10 is 14, so we're just doing 3 times 14, which is 42. Okay. This one, if the bounds are the same, then of course the area would be nothing, because you're not going from anywhere to anywhere. Okay, and then from 6 to 10, f of x, well, again, we have to kind of deduce this one. So from 1 to 6 is negative 2, but from 1 to 10 is 5. So if I draw out a number line, from 1 to 6 is equal to negative 2. So this is f of x. But from 1 all the way to 10 is equal to 5, then how much would this missing piece be from 6 to 10? Well, it would have to be 7, right? Because we're taking the sum of all of this and saying it's 5. So then this part must be 7, because 7 minus 2 is 5. So from 6 to 10 must be equal to 7. Okay, and then the last one, this is a composition of functions. So f of x plus 2 inside parentheses means we're shifting f of x left 2 units. So that means we're shifting it in the x direction. So we have to subtract 2 from both of these. So we get 1 to 10 of f of x. This is the same thing as from 3 to 12 of f of x plus 2. So then we check what we're given. 1 to 10 f of x is 5. So this is just 5. And that's it for the first section.